Here are three ways on how we can apply the integral of f prime x, fx to the power of n, okay, into these three questions. And this is equals to fx to the power of n plus 1 over n plus 1, okay, plus c. Okay, so as long as first you have to make sure that it's a product. So in this case, I make sure this is 3x squared multiplied by 1 plus x cubed to the power of negative half dx. Now, who is in the chain? This guy is in the chain. So my fx is equals to 1 plus x cubed. What is my f prime x? 3x squared, which just happens to be him. So if this is f prime x and this is fx to the power of n, all I need to do is to just apply this. I'm just going to get 1 plus x cubed to the power of, raise the power by 1, half, divide by the new power, half, plus c, I'm going to get 2 square root 1 plus x cubed plus c. So I would like you to write down that if you see f prime x over square root fx, a result of this, that means the integral of f prime x over square root fx is equals to 2 times the square root of fx plus c. As you can see, because when I integrate anything with a divide by square root means power negative half. When I integrate a power negative half, I'm always going to get a power half. And when I'm going to get a power half, it will always divide by half. Divide by half means multiply by 2. So that's why a result of f prime x, fx to the power of n is this, f prime x over square root fx. Okay? Next is a trick question. In this case, where I integrate secant square times tangent x. Okay, so this is a product, and there's no product rule in integration. Later on, you will learn by parts to know how to differentiate certain product. But when you see this, you can't use, okay, you can't use by parts. You have to be very sensitive. It feels like my fx is equals to secant x, isn't it? Because there's a power here. But don't be tricked, because when you which one is easier to differentiate, secant square or tangent? It should be tangent. If my fx is equals to tangent x, what is my f prime x? Secant square x. So we have to relate the differentiation of tangent as secant square. So this is fx to the power of 1. This is f prime x. So now when I integrate this, apply this into your question. The integral of this is tangent square x. Divide by, what is the new power? 2 plus c. And that's just the answer. Half tangent square x plus c. So don't be tricked. Don't see that secant square has a power. That is going to be my fx to the power of n. So not all the time. Okay, it's going to be in this way. Whereas for c is quite straightforward. Integral of e to the power of 2x bracket 1 minus e to the power of 2x to the power of 5 dx. Yeah, this is my fx to the power of 5. Okay, so if fx is equals to 1 minus e to the power of 2x, f prime x, differentiate negative e to the power of 2x. Is your differentiation good enough at this point? Yeah, if it's not good enough, so make sure you practice enough for a differentiation first before we come to integration. So this is my f prime x. Is it f prime x right now? No. Compensate with a negative half on the outside. Negative 2 e 2x 1 minus e 2x to the power of 5 dx. This is my f prime x. This is my f prime x. This is my fx to the power of 5. So when I integrate this, it's going to be negative half 1 minus e to the power of 2x to the power of 6 over 6 plus c. I'm going to get the answer 1 over 12, 1 minus e to the power of 2x to the power of 6 plus c. Okay, so this f prime x, fx to the power of n is a common skill you have to learn to use in H2 math.